In this lesson, we're going to discuss solving equations with absolute value. Our first example, the absolute value of r is equal to 9. If you recall, the absolute value of a number is the distance away it is from 0. So the absolute value of 9, what is 9 units away from 0? Well, negative 9 is 9 units away from 0, and positive 9 is 9 units away from 0. So one thing we may be look out for is we may have two different answers for this. We could have one answer or 0 answers, and we'll see examples of each. Here's another example. The absolute value of n plus 8 equals 18. Before you solve for the absolute value of n, you need to isolate the absolute value of n. So this positive 18, let's isolate this by subtracting 8 from both sides. And now we have the absolute value of n is equal to 10. Now if you recall from our last example, the absolute value of 10 can have two different answers. So n can equal positive 10 or n can equal negative 10. Both are 10 units away from 10. Next example. 5 times the absolute value of v is equal to 35. Again, I want to isolate my absolute value, so I want to get rid of the 5. So this is 5 times the absolute value, so I'm going to divide both sides by 5 to isolate the absolute value of v. Simplifying my 5, so now I have the absolute value of v is equal to 35 divided by 5, or 7. And then again, then this can split up and you can say v equals 7 or v equals negative 7 for this statement to be true. And if you go back and plug in, 5 times the absolute value of 7 should equal 35. Well, 5 times the absolute value of 7 is 35. Or if you plug in negative 7, 5 times the absolute value of negative 7 is equal to 35. The absolute value of negative 7 is 7. So this becomes 5 times 7 equal to 35, and you can always check your work that way. Next example, negative 7 plus 4 times the absolute value of b equals 13. So we're going to take two steps in one. First, I'm going to bring my negative 7 over. So add 7 to both sides. My 7 simplify, bringing down my 4 times the absolute value of b equals 13 plus 7. We have 20. Now let's isolate the absolute value of b by getting rid of the 4 by dividing by 4. Divide both sides by 4. The absolute value of b is equal to 20 divided by 4, or 5. And at this step we can say b equals 5 or b equals negative 5. Okay, so in this step in this example, we had two steps in this one. First, get rid of the negative 7, bring it over, then divide both sides by the b, and then finally set your b equal to both positive and negative to get that answer. Next example. Now we have inside the absolute value, we have something else besides just a variable. So we have the absolute value of 9k equals 45. Okay, so now we have two different answers in this one. We're going to say 9k, dropping the absolute value, is equal to positive 45, or 9k again, dropping the absolute value, is equal to negative 45. So I can get both solutions. Divide this one by 9, and you say that k equals to 5. If we divide this side by 9, we can say that k here equals negative 5. So again, there's two different solutions. If you plug in 5 for k, 9 times 5 is 45. The absolute value of 45 is 45. Or plugging in negative 5 for k, 9 times negative 5 is negative 45. The absolute value of negative 45 is also 45. So here's my two different solutions. Next example. The absolute value of n plus 9 is equal to 5. Okay, I'm going to split this up. So I'm going to say n plus 9 is equal to 5, or n plus 9 is equal to negative 5. Okay, subtract 9 from both sides. We could say here n is equal to negative 4. And again, do the same thing on the other side. Subtract 9 from both sides. And we could say here n is equal to negative 14. And both these solutions will work once you plug back in for n. And you can always check your work as you go. Alright, now let's combine some of these steps. We have negative 4 times the quantity of n, negative 4 times the absolute value of n minus 8 minus 1 equals negative 37. Alright, so our first goal is to get rid of this negative 1. I'm going to add 1 to both sides. So I have negative 4 times the absolute value of n minus 8 equals negative 37 plus 1 is negative 36. Then I'm going to isolate my absolute value by dividing by -4. My -4's go away, and I'm left with the absolute value of n minus 8 is equal to -36 divided by -4 is 9. Now once I'm here at this step, now I can separate the two and have my two different equations. So I have n minus 8 is equal to 9, or n minus 8 should equal -9. Solving for both sides, here we see n equals 17. Adding 8 to both sides here, we see here that n is equal to -1. And these are our two solutions. If we look at this equation for a second, this actually follows the same rules as if this was -4x minus 1 equals -37. So on a side note here, how would you solve for x? Well, I would add 1 to both sides. -4x equals -36, and then divide by -4, and we see here that n is equal to 9. The point here is we isolated the x, and the same concept goes here, as we're trying to isolate the absolute value of n minus 8 before we get down to this last step here. And one more example to be wary about. The absolute value of n plus 9 is equal to -1. The absolute value of n plus 9 is equal to -1. In this case, this is no solution. The absolute value of any number cannot be negative. Okay, so this is no solution because the absolute value of any number will never be negative. Now if you look back at this example here, we had a -37 here, but we also have a -4 and a -1. So first, isolate the absolute value, then look at it and say, okay, this is what happens after I isolate it. If you notice, the absolute value, what it's equal to, is actually positive. So don't make that conclusion until you isolate it. And then once you isolate it, if you're at this point here, where the absolute value of something is equal to -1, then you can say it's no solution.